So let's talk about this semester. So all you guys have had me last semester, so syllabus hasn't changed too much. You know how to find everything, you know where to find your Zoom lectures and everything like that. There's also going to be a morning lecture, and it's just going to be a morning lecture. Our labs are going to be in the evening, and then if you can't make it to that evening lab, then what you're going to need to do is meet me up in my office hours, at one of my office hours, and you'll be able to do your lab during that time. Okay, and I think Jessica has suggested that she may be able to kind of set you up since she's doing tutoring, so you may be able to hit up her tutoring sessions as well. Is that correct, Jessica?
Yes, that's correct.
Because she'll be recording her tutoring sessions.
Yeah.
So you're going to have two tutors this semester. I'll have to correct Jessica's hours because I wasn't sure if she was actually going to join us until yesterday, and I haven't had a chance to make the adjustments. And then also you're going to have Cameron Morales. She's also going to be tutoring for this class. And these are her her tutoring hours. And then I'll have a link that'll actually take you to her Zoom session. And I'll have her email attached to her name here in a second. Not in a second, in a while. Okay, so this is all the information that you guys are going to read on your own time. And of course, you guys know the objectives. So you're also going to be working with Chem 101, so you're going to get homework assignments again. You're, of course, although I know who all you guys are, you're going to have a school ID, a driver's license, or a passport so that you can show it during proctorial. And if you guys need a calculator, you can borrow it from the library. And so we're going to be picking up your lab kits February 5th, 6th, and the 8th. And there'll be sites at Coalinga, Lemoore, and NDC. So Taylor, you won't have to come all the way to Coalinga to pick up your kit this time.
Me?
Nice.
No, not Michaela.
Oh, sorry. I was like, I live in.
But I know you just like driving to Lemoore. It's your favorite thing to do, right?
Haven't been there in a long time anymore, but.
Okay, so I'm not worried about any of you guys dropping the class or anything like that, but these are the important dates down here. Even though it says 2A, I'll have to correct that. These are important dates, so the last date to add. So if you know anybody who's planning to take 1B, you know, we have plenty of room. The last day to drop the class is the 24th. I'm not worried about any of you guys dropping the class. Or I should say the last day to drop the class without having to pay money is the 24th. Then after that is the withdrawal. So the last day to drop it with a W would be April 23rd. This semester, I'm kind of changing things around a little bit to make it a little more accommodating than last semester. You guys feel a little bit overwhelmed? Angela and Taylor. I know Michaela was always overwhelmed, but you know.
Yeah, last semester, especially towards the end, I was pretty overwhelmed.
Yeah, so we're going to make some adjustments. So particularly with the lab reports, you're going to have 4 like really deep, in-depth lab reports. The rest of them are going to be kind of like you fill out the thing and all of that. And so the breakdown of your grade is going to be, again, your homework, your exams, your participation, your final. And then I've also added a portion that's called career preparation. So I'm finding out that a lot of you guys you're not thinking beyond West Hills. You're not thinking about where you're going to go next, you know, which course you're going to be taking or the pathway that you're going to be taking. So this is an opportunity to kind of do that. And so one of your assignments for this would be actually plan out your next couple of years. So you want to plan out at least 2 levels above. So I want to go to UCLA. So these are the courses I'm going to need. I want to get a degree in chemistry. So these are the courses I need to continue taking. These are the courses that I've taken. This is all that I'll have left if I go to UCLA. right? So something along those lines. So you kind of get an idea of your pathway that you'll be taking for the next 2 years. Plus, you want to look after that. So then that'll give me my bachelor. So what do I want to do after I get my bachelor? Well, maybe I just want to work. So then that way I'll just start looking for a job. And so what sectors would I look for a job? Where would I go find a job? Okay, so that's one thing. The other thing is part of your career preparation. There'll be, so you're going to find a person. So I'm going to try to put you guys in groups of common interest. And so you guys together find a person to sit there to talk to the class. And so your job will be to solicit that person, get them to come speak for like 20 minutes, 30 minutes about what they do and how much chemistry played a huge part of them understanding what they needed to understand. And so, so you'll have an idea by interacting with a person that's in the professional field. Okay. Questions, concerns, issues with that? Okay. Good.
Do we just find random people like on the internet and email them?
Yep, that's usually how it works.
Okay.
Or if it's somebody that you know personally, or that you know your family may know.
Okay.
Yeah. Okay, so so your group project. So I'll be sending you guys the papers that you guys wrote last semester for each of the groups. And so what you guys are going to do is I'm going to put you guys into 2 different teams. Ideally, we're going to have a NDC team, although I think there's only one person from NDC right now. Is that right, Graciela?
Yes, I was
Okay.
gonna be in the morning, but I fell asleep.
Slacker. Yeah. So so we may only have one individual from NDC. So what we may do is just have one person from Coalinga, and then we'll try to make arrangements for Graciela to sit there and interact either via Zoom or if she feels comfortable coming to Coalinga to sit there and help out with the project, then you know she'll be able to do that. So technically, you're only going to be meeting. We're only going to be meeting twice this semester for hands-on labs. So, and they're going to be 2 full days, and one of the days you're actually, well, it'll be 2 days essentially of labs back to back, and then you'll have the final where you'll have the day before the final and the final labs back to back. I mean, sorry, 1 day. I have to look again. You have 2 days that you're supposed to be here in person. Okay, 2 full days that you're going to be on campus, and that's it. And that's going to cover your part of your hands-on labs, and it's also going to cover your final. And then you guys kind of signed up for that, but there's only like 10 of you guys, so we're really flexible on those days. So we can talk about it, find a day that we can get almost everybody accommodated since there's only 10 of you guys. Any questions about that?
Did you post up the sign-up sheets yet or no?
No, I have not posted up any of the sign-up sheets. When you register for the class, technically you register for the lab day that you wanted. So.
Oh, okay.
Yeah.
Because that's why I think mine was supposed to be like Wednesday or Friday or something like that. But I was so confused because I thought that was supposed to be when the Zoom meetings were happening.
Yeah, no. Yeah, it was a hot mess when we were trying to get it all together. And they made all of these loopholes and all this stuff. And so I really think that also deterred a lot of people. Are like, what the fuck am I doing? You know, I don't know are you going to have the class 1 day of the week or, you know, so it's kind of crazy.
Oh,
so
okay.
All it is that we'll put days out and you guys can choose the day that's going to best fit your schedule for that lab day. And then we'll just plan to come that day. You know, we're going to try to get everybody accommodated in one setting if we can. Okay?
Okay.
Okay. So now about your projects, right? So you guys, I'll be sending out the paper probably towards the end of the week because I'm still trying to pull together your labs. I'm waiting for a couple of supplies to come in. So your project, so you guys remember the Uber project?
Yeah.
Yeah. So you guys wrote papers on that. So what you guys are going to do, you guys are going to rate those papers. Those top 2 papers that you guys, after you guys rate them, the top 2 ideas that you say, oh yeah, this is a great idea. So we're going to split you guys up into 2 groups. You guys are going to compete with each other. Since there's only 10 of you guys, we're going to have 5 in one and 5 in the other. and you guys are gonna push the project further. Now, what we're gonna do is have what we call an open lab day. Now, you don't have to come in if you think you can do all your formulations and all your everything independently, then you can do your formulations independently. All you have to do at the very end of the semester is provide that formulation and show that formulation works at the end. Now, the open labs are going to be, so me and the TAs are meeting every other Sunday for kind of just a general meeting to kind of touch base in terms of how things are going with all the different classes, as well as to kind of get our lab organized and kind of revamped a little bit. And those Sundays, it's going to be 4 hours that the lab is going to be essentially open. You guys can come in. There's also going to be a bucket seat for you guys to test your sample out on. So
At which
probably
campus?
it's going to be one at NDC, and there's also going to be one at Coalinga.
Oh, okay.
Yeah, I can't get one at Lemoore because I'm not officially at Lemoore. So although again, we have one person from NDC, so we may have to make some revisions on that part. But ideally, I'm going to try to get one located at both because we're going to use these bucket seats for future experiments. Okay. And so if you guys are planning to come in, you just got to make arrangements to let me know that you're coming in and fill out the COVID form and all that good stuff. Okay. Questions, concerns, Cash?
Are we gonna have to fill out the COVID form every time we go in?
Yes, and it's not as crazy as it was the last time. They've made improvements. It's all online and you can fill it out with your phone and all that good stuff. And so all I have to do is send you guys a link, you fill it out and we're good to go.
Oh, okay.
Yeah, anytime that you go to campus, you're gonna have to fill out the form. Even if you're going to campus every day of the week, every day you got to fill out the form. I got in trouble today, so for that, doing it. So I know firsthand. Okay, are there any questions? Good. Okay, so this will make it easy. During your lab pickup, I will have lectures for you. I already printed out most of them, except for I was using Mr. Bella's lectures, but I'm going back to my own lectures. I'm going to make some more changes to the lectures that I've started to generate and stuff like that towards the end of the semester because I didn't have a time to go over it with a thorough comb and stuff like that. So I was just trying to read a little bit and use his. And me and Mr. Bella's lectures don't quite get along so well because it's a lot of words and not enough pictures for me. And I have a very short attention span. So you'll be getting another set of lectures probably after the first face-to-face lab, okay? So, but you'll get lectures. So we're gonna be doing chapters 6, chapters 7, chapters 8. We're gonna do a little bit of chapter 9, which are gases, because we did the gases last semester, but there's a little part of it that I wanna kind of bring to the forefront because there's a lot of little discoveries that happened recently that kind of pertains to that little bit of that chapter that we didn't get a chance to talk about a lot. We just touched on. And then we'll be doing chapters 10 and above after that. Okay. Questions, concerns, Cash? Great. So everybody got a pen with them?
Yeah.
Yep.
Good. Okay, so you're already going to be talking to me about extra credit work, right? So there will be opportunities to get extra credit this month in February. So there will be an open mic night, February 18th at 5:30 p.m. If you decide to participate, like to say a poem or to do a dance or to sing or to do some crazy talent, I will give you 10 extra credit points towards your exams. If you decide to just attend, then I will give you 3 extra credit points. And so that's going to be February 18th. So if you're planning to do this, this is going to be a virtual event. This is not going to be face-to-face. So if you're planning to participate, you're going to have to record yourself doing whatever your extreme talent is. And you're going to have to submit it, and I'll give you the information to where to submit it to by February 10th. Did you guys get those dates?
Yep.
Yes, February 18.
That's right. Okay.
I can just imagine myself singing.
See, perfect. You're already there. And it'd be cool if all you guys sing together. You know, it'd be so much fun.
What time is this, Dr. Henry?
It's at 5:30 p.m.
We should form a chemistry a cappella group.
I think that's awesome. I'm 100% behind that. Okay, so on February 25th at noon, there's going to be a keynote speaker and a panel talking again about Black History Month. And I'll give you the whole spiel. There's going to be a little page and everything that you guys can click on to kind of get the information, because you're going to have to reserve a spot. And so on that day, that's going to be again at noon, and that's going to be worth 5 extra credit points towards your test grades.
Wait, was it February 25th?
February 25th at noon. Okay. Questions, concerns, Cash. Also, I forgot to mention this earlier this morning. Mesa actually has organic or the modeling kits for organic chemistry available for checkout. They also will have OChem. So also in the fall, how many guys are going to need to take OChem in the fall, or need to take OChem period? I know Michaela's an engineer, so well, what type of engineer are you got to be, Michaela? Is it mechanical or chemical?
I'm actually planning on graduating this semester because I hate the physics class here. So I'm just going to graduate with math this semester.
Oh, so you're going to graduate with a physics degree?
No. I'm not taking physics here. I don't really like the teacher. I just don't like
Mr. Zhao?
Well, okay, I don't want to say that. I love Mr. Zhao. He cares about his students. He's a good teacher. I just don't like his teaching style. It just doesn't click for me personally.
Okay.
So I'm just graduating with the mathematics. I'm actually taking the final semester of calculus this semester.
Okay. Sounds good. So none of you guys are going to be taking OChem? How many bio majors do I have? Graciela, aren't you a bio major?
Well, my counselor changed my major.
Okay.
Yeah, but I'm still taking biology, but in summer.
Okay.
Yes.
Okay. So we'll be offering organic chemistry in the fall. So if you're planning to take organic chemistry, keep that in mind and make sure that you guys register early so that we can make sure that we have the class going. So if you also know any students in Lemoore that will, in Mr. Abella's class, tell them that organic chemistry will be also offered in the fall. The more the merrier at the end of the day. Okay. So everything else you guys already know, because nothing has changed in that regard in the class. Are there any questions about the syllabus so far?
So when we're taking the exams, are we like using lockdown browser, or are we doing Zoom meetings with our cameras on, or how do we do it?
You're going to be using Proctorial. It's a fucking nightmare for me and for you. I'm just letting you know it's the truth. It is a nightmare.
Okay.
But it's the best that we can do right now. Lockdown browser always gave me a lot of grief as well too, but Proctorial is a little more friendly.
And the link to download that is probably in the syllabus, I'm guessing?
It will be for the exam. It'll be in the exam itself when you guys.
Oh, okay, I see.
And I just recognize that you guys actually have stuff that's already showing up that's not supposed to show up. So I've got to fix that. You know, apparently you guys already had a practice exam in December. So you guys take that?
Nope.
Yeah, I got 100%.
Yeah. So
That gives me
yeah.
extra credit now, right?
Of course, that's right. Okay, so with that, we can actually get started. We're going to have a short day. There's not going to be any labs today. Pretty much there's not going to be any labs this week. You may get a labs or demo for Thursday, but you know, you just got to do it. Let's see. Yeah, all this stuff is not supposed to be popping up. Let's see. So we are starting with chapter 6. So a couple of you guys kind of trickled in. So there's going to be a lab pickup at NDC, Lemoore, and Coalinga. I'll give you the specific times. That'll be Friday, Saturday, and Monday. I'll give you the specific times that I'll be there for those pickups. So you guys need to make sure that you guys attend during that time period. Or if you don't see me, you'll see the TAs. So you guys are very familiar with Jessica and well, you haven't met Cameron yet. And there'll be it's going to be a pull up, you drive up, we hand you the kit and you go. That's it. And if you already have the kit, you're going to get just an additional component added onto that. I know some of you guys turned in your kit, so I'll have those. Alberto, did you turn in your kit? You have your kit with you.
I have it with me.
Good. Okay. Good. So then all I'll do is get a nice little packet for you. So the two of you guys need a little packet. And Graciela, what about you? Do you still have your kit?
I turned my kit last time.
Okay. So then what we'll do, we'll give you back your kit, and then we'll also give you that new packet as well. Okay.
Oh, okay.
Wait, Dr.
So-
Henry, is that Cameron, the Cameron from my chem class?
Yes.
Oh, okay, yeah, I know who that is then.
Yeah, I think she was in your, wasn't she in your, wait, let me make sure. I may be lying. Hold on.
Jess, do you know if she was in the same class with us?
Yeah, she was in the same class as, yeah, you and, yeah.
Okay, yeah.
Everything's a blur to me. I can't remember who was in what class anymore. You know? Okay, so we're going to be talking about the electromagnetic energy, the Bohr model, development of quantum theory, electric structure, which is electron configuration, and periodic variation. So when we're talking about periodic variation, that's just kind of like, you know, how electrons play a part in the size of the atom, you know, and how the electrons plays a part in terms of the electron affinity and the electronegativity and things to that extent. And so we'll be talking about that. We'll kind of be touching on that. So this lecture set has a lot of equations. And so don't worry about memorizing them. The equations are going to be provided for you because, again, I'm worried about you guys getting concepts and not so much on memorization, right? Unlike my other colleagues. So, okay. So this is a picture of the Crab Nebula. So the Crab Nebula is like, I mean, look how beautiful it is. Very beautiful. You guys see that green color, the orange, the yellow, and all those things, right? See that?
Yeah, it looks like a stone for rings.
Yeah. Yeah. Did you guys, any of you guys watch, what is it? The Lord of the Rings or Ring of the Lords? What is it called?
Oh yeah, the Lord of the Rings. Yeah, I've
Lord
seen
of the
it.
Rings. Did you guys see that? Right?
Me, yeah.
Anybody else? Or am I just talking out of the side of my neck?
I've seen it.
You've seen it? Okay. So it kind of reminds me of the eye, you know, of, you know, the villain, the main villain that was trying to take over everything. Kind of reminds me of that. Anyway, so now if you actually take a look at this, right, it's actually made up of electromagnetic energy. So those colors are a result of light that's being emitted at different wavelengths. And those lights that are being emitted are a result of ions that are in that Crab Nebula itself. Like for instance, the green structure itself is a positive ion for sulfur, which is kind of rare. And then the red filaments are going to be a positive ion for oxygen, which again are very rare. But then that instability, that rareness, and them trying to come back to a normal level of excitation, then that allows them to emit that light. And so we're going to be kind of talking about that. And you'll start seeing how light plays a huge part in terms of chemistry, or how chemistry plays a huge part in light, okay? So what is electromagnetic energy? So basically, it's just part of it is just light, and we're going to be talking about different aspects of electromagnetic energy. But to kind of give you a little bit of history, it's been studied for a very long time. So Newton was like one of the earlier people to study in the 17th century, and he basically kind of realized that white light, the light that you get from, the sky and all of that stuff, is basically consisted of all of the different colors of the rainbow in a single thing. So basically we have all of these frequencies of light, represented by each of those different colors being combined in one single beam of that white light. And if we diffract those, we're able to sit there and see the individual colors that are there, okay? And so this had Newton start to think about things, and he said, you know what? Light is probably just made up of just tiny particles, right? Traveling at really high speeds, and that's how he kind of viewed light initially. Now, Thomas Young in the 19th century said, if we pass light through like a narrow slit, we can start producing what these interfering patterns, right? And so because these patterns are kind of interfering with each other, it can't be just straight particles that are going, because these things are going straight through, and so you don't just get these really discrete lines and everything. You kind of get these patterns of interference. And so because of that, he said, you know what? Newton's wrong. He's full of shit. It's not particles. It has to be waves. Because that's how you're getting that interference patterns, because we know that wave causes interference patterns. Because have you guys ever skipped stones?
I've tried to.
I've tried. Yeah, I've
tried?
never been successful.
Okay. Well, if you ever try to skip stones again, at first we had to get water so we can actually skip stones, right? So if you actually do it and then do it again, and you can actually see when waves kind of impede on each other, they kind of make an interference pattern. And so that's kind of like what he was talking about, was being observed. Okay. So then James Clerk Maxwell comes along and he says, you know what? He's like, maybe you're both a little bit right about this, And he says, light, what we call light, which is that white light, is just this visible part of the spectrum, right? And of that electromagnetic spectrum. And in reality, light is a combination of particle and waves. And so he basically comes up what we call the wave-particle duality. And then that is what actually fits the model of light, better than just it being a wave, and also better than it just being a particle. So it's a combination of something that's both of those things, right? So you guys are familiar with Einstein, right?
Nope.
No?
I'm just
You
kidding.
Never heard
Yeah.
of him before.
So if we go E equals mc squared, or 1/2 mv squared, and this is v, this is not new. So this represents velocity. This represents speed of light. M represents mass. Under both circumstances. Okay, so Einstein basically had this. So Einstein's theory of relativity, E equals mc squared. Basically, energy is proportional to the speed of light, and it's directly proportional to mass. So as mass goes up, energy goes up. Well, the speed of light is constant. It's always going to be the same. So the only thing that's going to be able to change is mass. So, and that kind of makes sense, right? So, for instance, if I throw a ball really slowly at you, right? And I hit Michaela with the ball, right? And I throw it slowly at her. Is it going to hurt too much?
Nope.
No. Now, if I throw the ball really fast at Michaela, right? Is that going to hurt?
I mean, it depends what it's made out of, but probably.
Probably, right? Okay. So the more energy, the more impact that's going to be felt by Michaela is going to be the one that has the most speed, right? The one that's kind of lofted, it may not hurt so much, unless it's a really heavy ball, but one that's thrown really fast at her is going to hurt quite a bit because that impact or the energy behind it is going to be much more, right? So does that kind of make sense? No?
I mean, I get it, yeah, but I'm
Yeah,
taking
I
physics,
understand.
so
What's that?
I said I get it, yes, but I'm taking physics, so we did
Okay.
this quite a lot, yeah.
Okay, so, and that's basically being shown here again, 1/2 mv squared, where v basically can be a variable. It can be changing velocity, velocity at different speeds, where this basically just represents the speed of light. This here represents the equation for determining kinetic energy, right? This here is just energy generally, or the energy associated with light, okay? Okay, so what is a wave? So how many of you guys have gone surfing or gone to the beach? Anybody like going to the water?
Yeah.
Yeah. Okay, so you guys all know what a wave is, right? You've seen a wave of water and everything like that, right? So it looks something like, right? So in the case of a wave, right? So the water crashing or the water moving up and down and everything like that, it has kinetic energy associated with it, right? So like say hurricanes coming in, the waves that are coming in, don't they have some type of impact on the houses that they're hitting or anything like that?
Yeah, it's basically because of the force.
That's right. So the force behind them is causing the speed of the wave to kind of increase, or in the way that we like to think of it, the frequency, may be increasing because of result of the waves themselves, okay, or that force that's behind it, okay. So if we look at the wave can be broken up into various components. We have what we call the wavelength, which is basically, that is a lambda, right? This represents wavelength. And that's just basically the distance from the peak to peak or trough to trough. Now, under a vacuum, under perfect conditions, or in a vacuum, a wave can go continuously and keep going and keep going. It doesn't dissipate, okay? Reality, it kind of dissipates because you have other things, other factors that are playing a part of it. So like when the wave comes into the, from the ocean into the shore, it's a little itty bitty wave, right? So that's not in a vacuum. So ideally, you're not going to have your wavelength being changed at a given point. Okay, so we have a wall here. So this here represents the wavelength. The number of peaks or the number of cycles that we have at a given time, that represents our frequency. So for instance, we have this wavelength, but let's say we have a different wavelength that's a little bit tighter. Okay, now don't make fun of my waves there. Okay, so now here are the wavelengths relative to the one up front, up top, is shorter. But the frequency is more. So over that given period of time, we have a lot more cycles that are occurring compared to this wave up here. Do you guys see that? Yeah, no, maybe?
Yeah.
Okay, now if this is light, we can sit there and say that the speed of light is equal to lambda, and the frequency is called nu. Like I got a new pair of shoes. So that's nu. That's not velocity. So nu represents frequency. Okay, so it kind of makes sense. If we know the speed of light is constant, it's 2.998 times 10 to the 8 meters per second. So that's going to be a constant. So if our frequency is big, then our wavelength is going to be small. And if our wavelength is big, our frequency is going to be small. Okay, so that means that they're indirectly proportional. Right? As one goes up, the other one has to go down. You guys see that? Yeah, no,
Yes.
no. Okay.
Yes.
Good. Okay. So we'll be talking about this guy named Planck in a minute. H represents Planck's constant. So as the frequency goes up, energy is going to go up because this number is a constant. If frequency goes down, energy goes down. Okay, so that's going to kind of be important later on. So kind of just keep that in mind in the back of your head, a whole bunch of calculations here, okay? Okay, so waves are not always restricted to travel through matter. So they don't have to go through water. It doesn't have to go through, it can go through the air. It can go through a vacuum. And like I said, in the case of a vacuum, we have the speed of light being a constant value. It's going to be 2.998 times 10 to the 8th meters per second, or often you'll see 3.00 times 10 to the 8th meters per second. Same thing essentially, depending on how many sig figs you want to look at. Okay. So we've talked about the wavelength. You guys know the wavelength. We've talked about nu. Now the amplitude is 1/2 from peak to trough, or just half the distance. So this basically represents the amplitude. Right here. Okay. Questions, concerns, Cash? So we talked about frequency. So units for frequency is typically 1/seconds or cycles per second. Okay, or we say hertz. So you'll see 1/second or hertz as your units for frequency. Okay. And so often you guys heard of megahertz, a gigahertz, when we talk about your computer processing speed, right?
Oh yeah.
Yeah. So they're just talking about the number of cycles that your computer can actually go through over seconds. Okay. Okay, so we've talked about this equation where C equals lambda times, and this is nu, not V, not velocity. Okay. And we know that lambda and nu are inversely proportional to each other. We kind of talked about that already. So let's kind of see that in a better drawing than I made. Okay, so here we have 3 different wavelengths. 1 is bigger than 2, 2 is bigger than 3. Okay, the frequency, this distance here, traveled in 1 second, is we have that's 1 cycle, that's 2 cycle, that's 3 cycles, right? That would be 3 hertz. So because the wavelength is smaller here, we have 1, 2, 3, 4, 5, 6 hertz. And then this one has 12 hertz. Okay, so as the wavelength decreased, the frequency increased. So that's what I mean by indirectly proportional. You guys get that? Good. Don't all talk at once. Okay, so this here represents basically the amplitudes. So here you can see a high amplitude and you can see a low amplitude. And you guys can see the difference between the two, right? Low amplitude, smaller distance from peak to trough. Larger amplitude, larger difference from peak to trough. Simple.
And the trough is like the bottom part
Yep.
of the wave?
Yep, right there. So that's considered the trough.
Oh, okay.
Trough. Yep. Yeah, it's called trough because have you guys seen pigs eat? Like they throw it in a trough and it's all dipped in?
Yeah.
Yeah, so that's where it came from. Started with the pig farmer. He recognized sign. I'm joking. Okay, so we've talked about electromagnetic energy. Now, so there's a spectrum of electromagnetic radiation or electromagnetic energy. So now this spectra basically ranges from, you guys have heard of gamma rays, the Incredible Hulk?
Yeah.
Yeah, okay. So we have from gamma rays to radio waves, right? So all of that are electromagnetic radiation, right? And so, and some of it is really bad for us and some of it doesn't affect us as much, but does have some effect on us over time, okay? So visible light is only a small portion of the electromagnetic spectrum. And I'm going to show you this in a second. And in the case of visible light, each different color light, remember visible light is a combination of all of the different colors. So if we have them all there together, that's going to give us white light. But if we break them up, each of those represents a different frequency and a different wavelength. That's okay. So this is just basically showing you the range of electromagnetic radiation or energy. So gamma rays are down here. So the wavelength for gamma rays are very, very fine. And that's also part of the reason why it's thought to cause a lot of problems with us. Those gamma rays, and we, I guess, form the Incredible Hulk, you know, not in real life. In real life, we die. Because it's actually able to, those waves are so small, I mean, the wavelengths are so small that that energy is able to kind of get into our cells and cause damage to our DNA and things like that. Same thing with X-rays, really, really small in terms of the wavelength. but the frequencies are large. Okay, so you have large frequencies, small wavelength. Okay, so as we go to UV light, right, it gets a little bit bigger. Visible light, infrared light. So like when you guys are using your remote and everything like that for the TV, or you're using the night vision goggles to stalk the neighborhood, hottie, So in those cases, you have I guess a moderate size wavelength, So then we have what we call radar and our wireless data. So then the wavelength gets larger in that case. Okay, and then as the wavelength gets larger, the frequency starts to get smaller. Okay, so here basically it shows us that as the wavelength increases, the frequency decreases. And then also energy decreases. Okay, because we know from Planck's constant, or we know that E can also equal H nu. Right? Do you guys see that? Are we good?
Yeah.
Good. Okay, so let's test those skills. So we have a sodium street lamp gives off yellow light that has a wavelength of 589 nanometers. 1 nanometer is equal to 1 times 10 to the minus 9th meters. What is the frequency of this light? So where are we going to start?
Wouldn't you just divide the two?
Okay. So you're saying basically what we're going to do is just rearrange this equation, right?
Yeah.
So what is C?
The wavelength?
C is the wavelength?
Wait, no. Hold on.
C is the speed of light.
Speed of light. Okay, so what is the speed of light? C equals what?
3. I don't remember.
I do not remember.
Come on now. I'm old, and if I'm old and I can remember. So 3.00 times 10 to the 8th meters per second, or 2.998 times 10 to the 8th meters per second, right? So that's what C is. So what is lambda?
It would be
Is
1
it-
times 10 to the negative 9th.
Is it just lambda is going to be equal 1 times 10 to the negative 9th?
Do
For
we
yellow light?
convert
What was
the
that?
we convert the 589 to the meters?
Okay.
Oh, yeah. You're right.
Okay,
I
so we're
just
going to convert that to
jumped.
meters. Boy, you guys are rusty.
It's been a year since I took chemistry, Dr. Henry, okay?
Oh, excuses.
I'm a math major.
So then this should be a piece of cake, right?
No, you don't have to do this in calculus.
Okay, so that's perfect. So then you can talk, when we get to vector, when we start talking about vectors, then it'll be your wheelhouse here. We'll be talking about that in a second.
Great.
Okay, so we can convert this into meters. So we get what? Times 10 to the minus 7.
Yeah, I got that one.
Okay, and then we just plug and chug, right? So we know that that's 3.00 times 10 to the minus, times 10 to the 8 meters per second.
Does it matter if we use like the 2.889 or the 3.00 for speed?
It doesn't matter. You can get away with rounding this to 3.00 because 3 sig figs. If you had 4 sig figs, you would end up using 3 sig figs towards the end anyway. So you end up with something like this. So either hertz or 1/2. Piece of cake? Yeah,
I just
no,
have-
maybe.
Try and remember the symbols. And then
Yeah, you got to remember the symbols. Even though the equations are going to be provided for you, but I'm not going to tell you what the C is and the lambda and the nu. Okay. Okay, so basically these are just a couple of either radio antennas or cell towers. How many of you guys have cell towers near you guys?
I'm sure they're nearby somewhere.
Okay. So cell towers, so they fall somewhere in the middle. So you have light and then like light radiation. And then right after that, we have, let's see, infrared and then, no, it's UV and infrared. So it's more on the infrared spectra part, right? So the cell tower would kind of fall in that infrared spectra, which again, they kind of believe has an impact on your cells. And partially because that wavelength, although it's bigger than gamma rays, and so we know that gamma rays does much more damage to us than, let's say, our cell. They kind of starting to feel that those waves of energy or that wave of light or electromagnetic energy are going to be playing an impact on us on the long term because we're constantly being exposed to those waves. How many of you guys sleep with your phone right next to your head? Go to bed with it?
sometimes.
Sometimes. Yeah.
Oh, what are your thoughts on the 5G? Like, do you think those types of waves would have like an impact?
I do believe that they're going to have an impact, and then but I think it's going to be time. So our lifespan versus exposure rate, and I think like your generation has a much higher exposure rate than my generation because when I was younger, there was no cell phone, right? Cell phones didn't come to play, or I should say, weren't affordable until I got in my 20s, you know, where you guys, I mean, my girlfriend's son has a cell phone at 7 and he is on it like 24/7, you know.
I understand that, like, I get that they're damaging, but aren't they still less damaging than actual white light, like from the sun? Isn't that still really bad and like way
Yeah.
worse?
And that's because again, the size of those wavelengths, the size of the sun, white light, is smaller, and so it's able to kind of get into your cells a lot more than those infrared lights. So if we go back to that spectra, oops. So here, this is where your cell phone is at. It's like radio waves, and then here's white light. So the wavelength here is much smaller. And you know what I should do? I have another slide that I probably should use for here so you guys can see the size of a cell. So cells kind of fall within this range. They're actually a little bit larger than this area right here. So in that case, you know, white light is able to actually penetrate the cell itself. Where these guys are a little bit bigger, they tend to damage the cell, but it's like it's the whole cell. It's not able to penetrate and get to that DNA level. So this guy is going to take more exposure rate compared to white light.
Okay.
Does that answer your question?
Yeah.
And so 5G is kind of like, it's still in that cell phone range, but it's a little bit higher than where it was at that time, just by a little.
Mhm.
Okay. Okay, so are there any questions right now? Okay, great. So I'm actually going to stop right here. I think I just wanted to kind of touch base, and you guys are already ahead because usually what do we do for that first day we introduce? So do you guys all know each other?
Let me see.
I know. I'm pretty sure Taylor was actually in my group last semester.
Yeah.
I only know Angelia.
I wonder how you know her.
It's a secret.
Hmm.
I just know Dr. Henry.
Well, why don't you guys all introduce yourselves to each other so you guys know each other? Since our class is only going to be 10 people, it's going to be real simple. It's amazing. I went from 100. We started off with like 112 people down to 50 people. School's
You
going to
should
start.
say who goes first, Dr. Henry, so we don't all talk at once.
But why don't you start, Michaela, since you're talking? The rest of them, they're all kind of shy. So.
Okay, well, my name is Michaela. I'm actually Angelia's sister. That's how we know each other. Now you're all in on the secret, and now we're all officially friends. Oh, and I don't know, I'm a math major graduating this semester. I've taken 2 semesters of chemistry with Dr. Henry before.
My name is Angelia, and I'm a math and science major. I'll be graduating next spring. So I still got another year left.
Excellent. So we may get to recruit you into inorganic chemistry.
My name is Taylor. I am majoring in agriculture, and I'm transferring out. Well, I'm going to be graduating at the end of this semester.
Okay.
Okay, my my name is Gracia Moreno. I'll be graduating this year, so I just have 3 more classes to go and I'm done. I don't remember my major, to be honest, because I've been changing my major to biology and then to math and science, so on. I've been with Dr. Henry. This is my 2nd semester with Dr. Henry. And I have 2 kids, a rooster and a cat. I am studying to be a vet, and hopefully I transfer to UC Davis.
Alberto, are you there?
Yes. Yeah, I'm here. Sorry. How's everyone doing? My name is Alberto. I currently attend. I'm sorry, I was chewing. Sorry, Dr. Henry. I currently attend Sacramento State, but I'm taking this class as a prereq for PA school. I was with Dr. Henry last semester, and I'm a kinesiology major. Yeah.
Mauricio.
So Mauricio Caldera. I'm a student here at West. I'm in biology. I will be graduating next spring semester and be transferring to UC or a different university. It doesn't matter as long as I transfer.
Okay. Okay. So our class is really, really small this semester. Okay. So there won't be any dropping. Nobody's dropping the class, right?
No.
No, of course not.
That's
Nope.
good.
Not yet.
Yeah, I don't hear not yet. So, yeah. Okay. Well, that's all I got for you for today. Are there any questions?
Are we gonna have lecture on Wednesday?
Yes, we are going to have lecture on Wednesday. We'll be getting through about half of the slides on Wednesday. We're going to have these slides for about 2 weeks. We'll finish it up next week.
Are we gonna go over like, I don't know, like sign up sheets or anything to pick up the lab equipment on Wednesday?
Yeah, we will talk about it. You'll actually get an email that tells you the directions of exactly what you need to do. And
Okay.
there won't be any sign up sheets. You just have to show up, and well, we'll get the information of where you're going to be. Because I think Graciela is the only one that's coming from NDC. Alberto, where are you going to be at? Or where are you at?
For what day?
So it'll be Friday, Saturday, and Sunday, and I'll be at Coalinga, NDC, and Lamora each of those days. I'll give you the exact times of when they'll be. So you just find a day that fits your time best, and if you just kind of let me know, so then that way, you know, I make sure everybody gets their kit.
This weekend, right? Yeah, I'll be
So
back
Friday, Saturday, and Monday.
Yeah, I'm gonna be back in Corcoran, so I can probably meet you in Lemoore. One of those days. I'll let you know.
Sounds good.
I can do Friday.
You can do Friday.
NDC. Okay. You said you're gonna be at NDC.
Yep.
Yeah, so I can do Friday.
Okay. And Ayla is in Lemoore, so again, I'll send you guys the times. I had to get those approved, so I just got the last person to approve me, actually just now, officially on the time. So I'll get a chance to see you guys. And all you guys, Mauricio, you have your kid or did you drop it off?
No.
You turn it in? Okay, so I'll make sure when you come and pick it up that you're able to get it. So okay.
I had one last question, Dr. Henry.
Yeah.
So can we attend the morning session? Like, is it interchangeable? Like, does it matter which one you attend?
Yes, it's going to be really interchangeable. The only thing, like occasionally I'll say a little bit more in the morning session, or I'll say a little bit more in the evening session, but essentially we're going to start at a certain slide and stop on the certain slide.
Okay.
In front of me now. Gotta keep track of that.
Alrighty.
Well, that's good to hear, because honestly, I could attend the Monday morning sessions, but I would have to attend the Wednesday night sessions.
Yeah. Yeah, we're going to try to make it so they're interchangeable. And then, of course, we're going to have the recordings available for you guys. It's going to take about a day or so to kind of get them up because, you know, I won't get this one until tomorrow morning. And I have one of the guys taking a look at them to see whether or not it worked for or if the captions were correct, you know, so. And then, so we're not, technically, we're supposed to make corrections to the captions before we post it. Any other questions? Well, I'm looking forward to seeing you guys this weekend when you guys pick up your kit. You know, I miss being in the classroom. You know, and my room is getting kind of stuffy from me being in it all the time. So
Me too. I hate online classes.
Yeah, I
me
do too.
Me too. I want to go out.
Yeah. Yeah. We're almost there. We're almost there. We almost got the vaccine done, you know. So what do you guys think about the variants?
About the what?
The variants, the like South African and what was the other one? The Brazil. So the
Oh, I
mutations that
haven't
are
heard
occurring
about
in this,
these.
yeah.
Great. I mean, I'm not surprised.
Mhm. It's beautiful how science works, you know. It's like, so as soon as you think you got, you know, something that's gonna kick its ass, nature says, oh no, it doesn't work that way. So again, so there's not going to be any labs this week. So, you know, we're just going to have our lectures. That'll be it. So kind of make use of that time. You guys, well, that isn't true. You guys are going to have a simulation to do. So
On Labster?
on Labster, yep. Yep, I'll get that set up for you guys. And this semester, your homeworks are going to be due on Fridays, and your labs are going to be due on Mondays. I'm going to switch them around a little bit. Okay, questions?
Nope.
Okay, I'll see you guys later.